Steel and iron production is reliant on coal, both as a feedstock and a fuel. Unlike cement, emissions rise at different points in the steel production process. Steel mills have a number of furnaces and subunits involved in the production process that emit carbon dioxide. The largest of these are the blast furnaces and the on-site power plant. Steel production is an energy-intensive process as it requires high temperatures to transform iron ore into steel. The energy and the heat from the processes comes from fossil fuels, which is primarily coal. The use of fossil fuels means the average CO2 emissions from steel production is about 1.85 tons of CO2 per ton of steel produced. In fact, between 7 and 9% of all fossil fuel-based CO2 emissions are derived from the steel industry. The amount of steel produced in 2018 was 1.8 billion tons, which equates to about 3.3 billion tons of CO2 emissions. If we counted the emissions of the steel industry as if it were a nation, it would rank as the 5th largest in the world. The complexity of the steel production process provides a variety of challenges. The main challenge for steelworks is choosing the most effective site to install capture technology, as there are multiple emission sources on site. A number of solutions are possible to bring steel to net zero. In the long run, technological changes to the steelmaking process can reduce emissions by producing clean steel. However, this technology is still way off from being commercialized, and it will require large modifications to the existing steelmaking infrastructure. The best way to decarbonize existing steel plants is to use CCUS on the blast furnace to capture and store or utilize the carbon dioxide. In some cases, the carbon dioxide can be utilized with water and a plant waste, known as slag, to produce construction materials. Valorization of the captured carbon in this way can provide an additional revenue stream for steelmakers.